Hello, folks. Welcome back to another episode of the Building HVAC Science podcast. Hey, I'm just going to read you some quotes from the episode, and let's see if you can figure out what we're talking about here today. We're not undoing cooling with reheat. We're using that energy to do something else useful. Regenerate the desiccant. Liquid desiccants are the honey. They're like the honey of HVAC, safe, natural, and surprisingly powerful. It looks like an air conditioner. That's what contractors tell us, and that's the point. So these are some key quotes from our conversation that Elk and I had with Phil Farese, who's the CEO of Mojave HVAC, where he's going to explore with us the cutting edge of desiccant dehumidification technology. We're talking about liquid desiccants, something I've never really even considered until I heard from Phil and we started to talk about this. He covers his background, majoring in physics and working in research at Princeton and then for the National Renewable Energy Lab, and how he's improved upon an idea that was actually patented back in 1930. He's got a lot of cool stuff we cover, and he is actually rolling out now tech training programs, a broad rep network already in place. And then we talk about ideal use cases and some of the efficiency standards, which he's proving to perform very well against competitive devices to do the same effect, to dehumidify. A lot of great links in the notes. We hope you pay close attention to what Phil Farese has to say about beyond vapor compression, smarter DOAS with liquid desiccants.
Hello, everyone. Welcome back to the Building HVAC Science podcast. Bill Spohn right over there. Eric here. And a special guest today. We've got Mr. Phil Farese from Mojave HVAC. And Phil, I understand you are here to talk about desiccant dehumidification, which is an interesting topic, and I don't think one we've ever touched on before. Have we, Bill?
No, it doesn't ring a bell. And this is actually unique technology Phil's going to unravel for us today on the podcast. Welcome, Phil.
Thank you for having me.
Great. First, we always like to start out with a little background on our guests so people can calibrate and orient, and you can catch us up to what got you to here, both with your company and with coming on the podcast.
Yeah, certainly. Glad to share my background. It's pretty wandery, I would say. If I was going to do a theme to it, a lot of people say, hey, this is what I wanted to do. I would say I wanted to learn. And so it started off as a physicist, got my PhD, and was doing teaching and research as a postdoc at Princeton University, and then decided to head in a different direction and into the business area. Joined the consulting firm McKinsey and Company, learned a lot about things. I loved technology at the time and thought I'd head in that direction. But once I came across energy and the climate situation that we're all facing back in the early 2000s up to 2010, fell in love with that problem and really got into energy efficiency. Published a report that I can't believe is now 10 years old, more than 10 years old, looking at, is energy efficiency real? Why don't people do it? What does it really cost? And getting a lot of the facts out there for that. And that actually led me to the National Renewable Energy Laboratory, NREL. I was stationed in DC, so really in the thick of it there in the Department of Energy's offices, helping all the efficiency programs, think strategically, do a bunch of reevaluation of some research areas and thinking about deployment as well as R&D and codes and standards. And that's actually when I met liquid desiccant for the first time. It was something NREL has a long history of doing and was working with that group. It went into our prioritization of different technologies. And one of the things I realized and wrote a paper in Nature on at that time was that there's two really big things that needed to change in energy. Again, this is as of 2012, 2014. One was lighting. If you remember back then, that was the CFL era was coming to an end and LEDs were getting started. And I would say everybody hated CFLs and everybody loves LEDs. And there were tons of lessons learned there about what it takes to make an efficient product actually successful in the market. And if you think way back, you guys are my generation here, so you'll remember changing an incandescent bulb a couple times a year. Don't even think about it anymore. And, there were like billions of dollars being poured into LED lighting, and it's been a very successful story. The other big opportunity is, frankly, HVAC and a lot of air conditioning. And there was a fraction of the amount of money, a fraction of the amount of interest there, partly just because the vapor compression system works so well, your standard direct expansion, DX, whatever you want to call it, AC system. And yet liquid desiccant is this one thing that offered a new way of doing things. That actually led me to a company called Avantic Systems that tried to do this about 10 years ago. That's a long story as well, was partially successful, but in the end wasn't able to get it across the finish line. And I actually then got pulled into solar for a while. So a company called Enphase Energy, they might know, they were going through sort of a big turnaround that I helped with and got them set on the path to be a Fortune 500 company. and moved on from there to the finance side, learned through both of those experiences at Enphase and at Advantix how important it was to keep your eye on the financial situation and really understand how investors, both in the public sector and the private sector, think about that. So I learned a lot of things at that hedge fund and then took a pause to figure out what I wanted to do next. And this opportunity here with Mojave just pretty much fell in my lap. A former colleague of mine had been helping out Xerox. So sounds like a strange company to be starting off on this. When Xerox, if you know, had this great research center, Palo Alto Research Center or
Park.
Yep. Famous for having licensed a lot of technology to Apple, which made them very successful. Some people will say Park was instrumental to inventing the internet, which is certainly true. I forget which P, but one of the P's in TCP/IP is for Park. And then they were trying to invent the office of the future, and then they got a little bit more broad and ended up doing a lot of government work. And for the last 10 years, one of those things was what they called the Clean Tech Tower. So where they're looking at energy. And they had started off thinking about alternative ways to store energy. Obviously, if you want to get to high levels of renewables on the grid, you need a way to store electricity. And they said, hey, there's this technology where you can basically concentrate and dilute salt water. Electrodialysis is the basic idea there. And they had a breakthrough around that. And then as they looked at deploying that, they said, economics, the technology isn't quite right for this. Let's see if it works for anything else. And that's when somebody said, which is exactly what you hope for in Park, right? You got all these people tossing around ideas. I said, well, have you ever thought about liquid desiccant air conditioning? And then pieces started coming together and they got to the point where they had a team of about 15 people working on it. They had a first prototype and they were about to go through a bunch of transitions. So they said, hey, we think we got something here. Let's spin it out, which is when I got involved in 2022. And then officially September of 2022, Mojave got incorporated, and early 2023, we had spun out, gotten our first round of investors, got set up to start deployment, and we were off to the races.
Yeah, nice. You're one of a rare breed of people I've met, and maybe just my circles aren't that large, but that combines research physics with business. That's fantastic.
Yeah, it's not about your circle. There's not a lot of us out there.
No, there aren't.
As I said, it was not something I set out to do, but just been very fortunate that all of the pieces came together and just had this great education, if you will, over the past 20 years to get really set up for this role.
And if you don't mind sending us links to any of those papers that you mentioned, either previously in the conversation or in the future, we'll put them in the show notes links, because a lot of our listeners are autodidacts that people just love to learn, and we'll dive deep into some of these topic areas. So we love to feed them, right, Eric?
Oh, yes, very much. Could feed that all day long.
Yeah, certainly.
So the phrase liquid desiccant just rattled my brain a little bit when I heard it, because I think of liquid, generally the most abundant liquid that I know of is water. That's probably not what you're using for desiccants.
In a sense, 70% of it is, and the rest is salt. So it's basically a very concentrated salt water solution. There's a lot of different liquid desiccants. There's different parameters that you care about when you do it, but we use, I would say the most proven one goes back 30 years to when Cathabar first started doing this, actually maybe 40 years ago. So very well field tested is lithium chloride. So it's sodium chloride is table salt. This is very, very similar, just much better at holding onto water. Other things that you would know that might be surprised are liquid desiccants. Honey is a liquid desiccant. So honey is going to absorb moisture. Glycol, more on the nerdy HVAC side, is a liquid desiccant. But lithium chloride is what we use, again, for very good reasons. And you're right, it's a very counterintuitive thing. Whether we know it or not, we're very used to desiccants in certain settings. So like if you buy a pair of shoes or a piece of electronics, they come with those little packets that have like pellets in them or whatnot. That's a solid desiccant, so it makes a lot of sense. It's just going to absorb the moisture onto the surface and pull that out of the air where it's in, so it keeps moisture down so you don't get things damaged. Liquid desiccants, pretty much the same, a little different. It absorbs the water actually into the solution, and in doing so dilutes itself. So it's more, I would say, counterintuitive. If I take water and spill it on the ground, you'll see a little puddle, and then over time that'll evaporate. The rate of evaporation is going to be really high if it's really dry. It's going to be a bit lower if it's really humid, but you're rarely at 100% relative humidity, so it's eventually going to evaporate. If I spill liquid desiccant, it's actually going to sit there basically forever. And it's going to grow and shrink in size of that puddle, basically coming to match whatever the humidity is in the air. You got to be careful when you spill it, clean it up with a rag and whatnot, but it's otherwise just a liquid and just something that's really good at absorbing moisture.
The rate of absorption must be related to surface area?
Yeah, exactly. Surface area, surface chemistry, rate of airflow across it, all those things. Exactly right. So when we use it for technology, it's a curiosity. If I just spill some and whatnot, obviously that's not going to help me make an air conditioner that really dries things out. So you got to engineer a whole system around those concepts you just mentioned there, surface area, and then how you manage the water in that fluid.
Is atomization control really important?
Oh, very good question. Wow, you're getting deep fast. So yeah, one of the central things, maybe let me take a step back before I answer that and just tell you how we use the liquid desiccant, and then we can get into that question.
Please.
But we don't only have a liquid desiccant in our system. Our model is called the arc to dry. And the reason that we developed this technology is vapor compression systems are great. They're very good at cooling air and also at dehumidifying it. In fact, if you go back to, I always get the year wrong, 1902 or 1908 when Carrier first invented the air conditioner, the reason he did that actually was to remove moisture. And then it was great invention for 60, 80 years at having what you call the right sensible heat ratio, the amount of water you remove from the air to the amount of heat you remove to the air, where sensible is the heat, latent is the water. And a basic air conditioner like that, a vapor compression system, is going to pull out about 70, 80% sensible, 20, 30% latent. Fantastic. But nowadays, especially when we're ventilating, when we've got those LEDs in place, when all that sensible load is coming down and the latent load is going up, you're having to get more and more moisture out of the air. So you got to cool that. You got to run that air conditioner longer to get to a colder temperature on the part that's removing moisture from the air, the evaporator. And then your air is too cold, and you're probably familiar with like a DOAS, dedicated outdoor air system, with a reheat coil. And that's to get the air back up so you're still comfortable. So what we do is we basically say, love vapor compression. You're just deploying too much of it and running it too cold. We can basically downsize that vapor compression system and stick it in the same exact box with a liquid desiccant system, where the vapor compression system comes first, so the air comes across. You got the vapor compression system, pulls some of the moisture out, cools the air down to technically this target enthalpy that you want to be at, or the right spot, if you will. And then you pass it through that desiccant, and the desiccant does the job of reheating like that coil does, but it's not wasting energy because at the same time it's drying. It's doing that same process there. So I can dial in those two systems basically independently to get the temperature and the dew point that I want and just deliver it at that right spot, which sounds simple and obvious, and it kind of is because the patents go back to 1930, but then all the hard engineering comes in, and there's a few problems you need to solve. So one, the core thing you really need to do is that liquid desiccant, like we mentioned earlier, is just going to pull moisture right out of the air. So you got to pump it. We use a media bed. I'll come back to that, where we get a lot of surface area. Air passes over it, pulls that moisture into the system. But of course, once you pull enough moisture, it stops working. So simultaneously, you're pumping over a small amount of that to another media bed where you're going to regenerate the desiccant. And that's also pretty easy to do in principle. I just got to heat up the air and heat up the desiccant. So basically, you can think about it as lifting the desiccant uphill, water flows downhill. So I'm basically lifting up the desiccant up a hill. Technically, it's kind of the vapor pressure. So I'm raising the vapor pressure. And now that moisture is going to flow out into some exhaust air. And I can do that really efficiently just basically by taking the condenser air that I had from my vapor compression system at that front, heating up some air. That's going to heat up the desiccant, drive that moisture off. And now I just have a cycle. So I can just run that cycle. And basically by controlling how much heat or how quickly, if you will, I'm rejecting that moisture, or how much heat I'm putting into that desiccant and driving off that moisture, I can just dial in the desiccant and therefore the dew point, or the desiccant concentration and the dew point that I want, and also dial in the temperature I want. Because I got two things I want to control, sensible and latent. Now I got two knobs. I just dial them right in. Easy enough, but it took us a patent to get that to work. We have a patent on that. So very, very important. The other thing that's kind of important there is we have a very reliable system. So historically, these systems have been pretty complicated. You want to heat up the desiccant with maybe some water, is like what Cathbar used to do, and cool down the desiccant with some other water. You need to have heat exchangers there. We eliminated all of that and can do this all with air. So just the air coming off of that evaporator from the DX system and the DOAS is going to cool the desiccant down enough to absorb moisture. And in the same way, coming off that condenser, you're going to heat up the air enough to drive the moisture off on the exhaust side. Another patent we've got there. The third patent comes back to what you had said, which is there's different ways now to get all that surface area over in contact with the air. So a lot of surface area contacting the desiccant in the air. The challenge there is if you were to atomize it, you typically get, again, I'll get a little nerdy here, but you get like a power distribution of droplets. And some of those droplets are just going to fall into your sump and be fine. But some of them, they get entrained to the airstream and pulled out.
You get slip. Yeah.
Yeah. So it sounds like you're familiar with that, Bill.
Yeah.
So we don't spray for that reason. We don't atomize. We basically have this manifold that distributes it right onto this media bed pad. And if you're familiar with a media bed, like in a cooling tower, you go to a major cooling tower, you're going to see like water just gushing down this thing and like flying off and so on. So we come nowhere near that flow rate. We keep it, just as the manufacturer suggests, with quite a bit of safety factor, well below that. So the desiccant just like bonds onto that. And it's almost just like a big sloppy sponge. And the desiccant's just kind of always flowing and keeping that wet, but none of the desiccant gets pulled off into the airstream. And we've proven that down to better than less than a part per billion. So we're very, very sure that one, you never have to replace the desiccant. It lasts the whole life of the unit. And two, you're not getting it into the airstream. So you're not going to rust out our unit. You're not going to cause any damage to your ducts. And we believe that so much that if you were to look at our system, again, we've got that vapor compression system, the evaporator. Then you've got your desiccant system, what we call the absorber. Then we got a fan. Then we got our heater, and so on. So we can optionally have an electric, gas, or other types of heater. We're putting our money where our mouth is. If anything was going to fail first, it's the system there. And we have a 5-year warranty on both our vapor compression system and the desiccant system, 2 years bumper to bumper. So we are very, very confident that we've solved that problem as well.
Nice. So I'm curious, listening to this, I've worked on some systems in the past that actually used water, essentially water as a desiccant by heating and cooling the water to either absorb or reject. Can this system be reversed to where it can add humidity to a space as well if it's necessary?
In principle, yeah. So there's 2 ways you could do that. It's not something we offer today because we haven't had a lot of customers ask for it. But one way you could do that is you could basically have a water fill line going into that absorber. So let's say you have a data center and you really want to hold the humidity to like 60% plus or minus 5%. You could very easily just have a valve that's controlled by the humidity. If you put water then into that absorber and mix it with the desiccant so it dilutes, it's actually going to humidify because it'll be more humid than the target that you want. And then when you get to that, you can just let it come down again and dry again. So there's that approach. Then there's another one. Now I'm getting way ahead of myself because this is something we're probably going to do in a couple of years, and I'll probably get in trouble with somebody for sharing this with you, but I'm going to go ahead and do it anyway.
Oh,
We launched this year our heat pump. That DX system at the front is a reversible heat pump today. So we can give you kind of electrification. In the winter, we can operate down to 10 degrees Fahrenheit, pull that air from outside, heat up the system. We don't humidify today, but we're working on an approach where you'd be able to pull out even that limited amount of humidity you have in outdoor air and bring it into the system, maybe combined with an ERV. And I should mention, we also do offer an ERV unit today as well, so we can combine that. So in principle, yeah, if you have enough humidity and you reverse that whole cycle, you could pull the humidity from what was formerly your exhaust air, use that to heat and humidify a building, but we're not quite there yet.
nice. I mean, that seems to me like anything we can do to reduce what I want to say raw materials or raw resources tends to make things more efficient overall when I think about them, rather than pulling that water in from, say, a water supply and going through all the filtration that's going to take. If we could just drop that out of the outside air and bring it in.
Yeah.
How about the size and from 2 different approaches, the design size, the impact that it has on the airstreams, as well as the physical size of the system? If you could answer those 2 questions.
Yeah, certainly. So one of the challenges, obviously, is to then package this, get it onto a roof. So testament to our vice president of product, Aaron Mells, who was with me at Avendix many years ago, was at Specified Air Solutions and other places. Like, he knows the industry. And so he's been the architect of pulling that all together. So we've basically targeted this to make it as installer-friendly, contractor-friendly as possible. So single-point electrical connection. Obviously, if you go with one of those heater options where it's gas, only a gas hookup line. We have tried to keep the weight and the size as close as we can to conventional equipment. It is going to be a little bit heavier and a little bit larger just because we've got that second air tunnel. So obviously, you need a little bit of extra size and mass to handle that. But I would say most of the time, you're not talking about something that's so much heavier or so much larger that you would need to redo all of your structural. Sometimes if you're talking about an older roof, that's true. But look, if we're basis of design, which is really the best way to start talking about how to employ the system, we're really finding things moving very, very smoothly going forward.
How about the capacity that it has?
Yeah, certainly. So we have a building out the line, but I'd say we hit about 2/3 of market needs right now in terms of that core DOAS market. And I'm going to talk about 3 aspects of capacity. So one is just airflow. So right now we go from 1,000 up to 8,000 CFM of airflow. That's in 2 different cabinet sizes. So you got one that goes 1 to 4,000, one that goes kind of 4,000 to 8,000, or even 3,000 to 8,000. Second aspect, of course, is then capacity as far as tonnage. So as I mentioned, we can get more done with that same compressor that you might put in another unit. So we talk in terms of effective tons. And there we're covering up from 20 tons all the way up to 60 tons. And that's in different sizes of compressor. Just as if you were going to call in ever competitors, this is that configurable approach. So it's not custom, but you're going to specify things that'll go into a design string. You specify the size, the airflow, heating options, whether or not you want coated coils, et cetera, et cetera, et cetera. There's probably 10 or 12 different things you specify there, all the way down to what hoods you want and what dampers you want. But again, we cover that full range from 20 up to 60 tons. And then third question is dew point. So what dew points can you get down to? And we can actually get down to a 35-degree dew point. 42 is all basic, straightforward process. 35, we just do a little bit more checking to make sure, since you're going to be pushing things. But again, we're very able to do that, which basically allows us to get not just your core DOAS applications like a hotel or a school where you're just trying to treat air and get it down to like a 50 to 55-degree dew point, but also things like grocery stores, any kind of industrial or food processing things where you're really pushing down to like that 35-degree dew point because you got to get to drier conditions.
So this is more than a concept. It's a product on the market. There are installations, correct?
100%. Yeah. We got millions of dollars sold already and out there. We manufacture actually in Anderson, South Carolina, looking to get a bunch more out this year and have the sales pipeline to do that.
I was going to say, that's an impressively low dew point to get to 35. That's some pretty dry air.
Yeah. No, thank you. That's maybe a good point to compare to some other technologies. So the way we think about it is liquid desiccants great at most of the market, and this is a little bit on the very, very low end. So if you want to get down to like a lithium ion battery manufacturing, if you've ever seen these, they're like at 1 grain per pound, 2 grains per pound, like super, super dry air. It's like a negative 20-degree dew point. Technically, liquid desiccants can get there, but not this system. You'd really need like an ammonia chiller and cool that desiccant all the way down to like negative 10 degrees or so to get to that kind of a dew point. So we're not doing that. There, you're going to go with a solid desiccant, but basically anything down to like that 35-degree dew point, which is, again, the majority of the market, we're going to be able to meet customer needs. Typically in that, let's call it 45 down to 35-degree dew point, that's really where you'd be talking about a more specialty piece of equipment like a solid desiccant wheel. In essence, if you look at the solid desiccants, it's a very similar architecture to ours. The really efficient ones do have a vapor compression system in there. I would say compared to them, we find that we're a bit more efficient because we can regenerate that desiccant, that casting off the moisture that I mentioned with that regen air coming off the condenser. We can do that at lower temperatures, which just means a more efficient system there, just the nature of the liquid desiccant. We also don't have belts. We just have these little pumps, under horsepower pumps that are moving the desiccant, much easier to move a desiccant than spin a big wheel. So maintenance is a little bit easier. It's a bit more energy efficient in that range there. And I'd say price-wise, we're finding we're basically the same, maybe even a little bit lower in some applications versus those solid desiccant wheels. On the higher end, back to those hospitals and schools, we're really talking about a DOAS with a hot gas reheat there. I can almost make an analogy there as well. We're actually very similar to a hot gas reheat, where we mentioned, again, you'd be coming off that coil at some dew point that you want to get down to. You want to reheat the air. So you're taking some of that heat that you pumped out and putting it back into the airstream to heat it up again. That architecture is basically the same refrigeration system for us. We just don't waste energy by sticking it back in that reheat coil. We toss it outside and use it to regenerate that desiccant. And that's, again, how we get that dehumidification. So we're doing much more useful work, not just undoing the cooling that we did there. So that's the main comparison there, which is why, again, we're going to save 30 to 50% versus a system, which we can have third-party testing on that. There's actually a paper that NREL is working on. We're partnering with them that we can share that shows exactly what our rating is. Are you guys familiar with the DOAS ratings that are out now, the ISMRE?
No. I was going to ask about that, of like effectivity per watt kind of thing.
Sure. Yeah, certainly. So if you're talking about your standard commercial air conditioner, you would use an IEER, an integrated energy efficiency rating. Just to draw an analogy to that, you test that at 4 points. Return air, it's like 100%, 75%, 50%, and 25% loading and different outdoor air conditions. Since a DOAS, the real challenge is really about that moisture removal and delivering at room neutral air. We have replaced and actually just now have to rate all DOAS units as per DOE rules that came out this year to this other standard, AHR 920, if you want to look it up, which is an ISMRE, so Integrated Seasonal Moisture Removal Efficiency. That is also tested at 4 points, but now instead of being at those load fractions, you're actually taking the outdoor air at 4 different conditions, kind of your typical Miami conditions, like I'm not going to remember them exactly, but 90, 120, down to like your cool, wet conditions where you hate the fact that you need to run an air conditioner. Like if you ever go to the grocery store, you go in, it's 70 degrees outside, it's like 50 degrees in the grocery store. So that's exactly the problem we're trying to solve there. You're going to run this unit when it's cool and wet and just give you warm, dry air. So you tested those 4 points. To sell a DOAS today, your ISMRE needs to remove 3.8 pounds of water for every kilowatt hour. Our units, depending your airflow and where you specify it, run from 9 to 11. So we're almost triple the standard. We find that, we're about 50% to double what you're going to get from your typical vapor compression system today, which is why we get those great energy savings at 30 to 50% that I mentioned earlier.
Wow. The magic's in the liquid.
Exactly.
You had mentioned before we started that you're working on some programs for technicians. I imagine because you got units in the field, you got design nailed down, but perhaps installation and service are some of the areas where you plan to grow and kind of communicating the knowledge that's needed to do this and achieve the best.
Yeah, that's exactly right. Three aspects of that. You've got your install, you've got your preventative maintenance, and you've got your break fix. And I would say each of those is, you need to talk about independently. So install, again, is very straightforward. You crane it up where you need to do it, or you put it on a pad next to the building. You hook up your air and your electrical. You may need a curb adapter if you were in basis of design and replacing something existing. But any contractor out there is going to look at this and basically, this is one of the, I would say, most exciting, but probably most boring pieces of feedback we ever got is like, well, it looks like an air conditioner, which when you're talking about a new technology in a generally appropriately risk averse market, like that's great feedback. And so that's what we get there. We do startups at this point. So we're going to include factory startup up there. We have one of our tech show up. They're going to load the liquid desiccant. They're going to make sure it's got the right amount in there. They're going to make sure that it starts up properly, that everything's done. Of course, we've tested that in the factory ahead of time. We're going above and beyond right now, in addition to kind of your standard, start everything up, make sure the fans run in the right direction, do all of your standard test points. We actually run the unit for a couple days just to make sure that across a range of conditions, it is meeting those specifications. So startup is straightforward. Maintenance is also straightforward. What are the three things that you mostly do with an air conditioner? You should change your filters, right? We all do every quarter, just like we're supposed to, right? Which reminds me, I think I got to do that in my house. Number two is you may clean your coils. So you may want to clean your evaporator coil or condenser coils. Third thing, of course, is check your P-trap and your condensate drain line. So you're going to do all those with the usual frequency. The only thing we add to that is our desiccant system has a liquid phase strainer. That strainer is actually permanent, so you don't even throw it away. But what we recommend is that when you change those air filters, you basically inspect the strainer. If you see any particles in it, and because sometimes dust or other things are going to get through that air filter and get in there, you literally just rinse it out and put it back in. It's a 5-minute job. So very, very easy.
So rinsing it out, the lithium chloride, does that also in the filter? Is that something that has to be handled in a different way?
So it's very safe to handle. I'd say you want to pour it back into the sump, which is easy to do. What you rinse out, the EPA does not see this as a hazardous material. We, of course, recommend you wear gloves. It can be just like if you get salt in your eye, right, it burns. Same thing. It's just a lot of salt. It's 10 times saltier than seawater. So you're going to get that sensation. People ask, like, is it toxic? I like to point out the typical way that you do this is the LD50, the lethal dose that would kill 50%. It's about the same LD50 as caffeine. So I would challenge anybody, well, I wouldn't actually, but I don't think anybody would drink enough gallons and gallons of coffee. You wouldn't drink gallons and gallons of desiccant either. So pretty safe there. There are certain states that do, like California and Massachusetts, that do have disposal requirements for it. But most of the states, it's totally fine. So we include that in our IOM, our instruction and operation manual. Very, very easy to handle.
And I see on your website, which we'll include a link in the show notes, that you do have a number of different reps that are trained design and also the service aspects, the installation service.
So a little bit less the installation service. We're starting that up this summer. So beginning with some of our reps here in the Carolinas and moving out, we're going to be training, if you will, the service technicians that they recommend that are nearby. We're going to open that up more broadly once we've kind of gotten initial feedback on that so that we can have third-party technicians that are, if you will, certified to handle the equipment. As I mentioned, the standard preventative maintenance, very, very straightforward. I would say that the kind of any break fix maintenance is also similar. As I mentioned earlier, the refrigeration system looks just like a DOAS. We just put the reheat coil in a different place. So you're going to look in here, you're going to see a compressor, you're going to see all the filters, the coils you expect. You're going to see a 3-way reversing valve. We do use some of the more, I would say, reliability focused components. So we have an oil separator in there. We've got a receiver in there. So there's those. But again, any trained technician is going to recognize those. We use 454B, again, both for the low global warming potential and because you have to now, but we had always used that. We switched to that. We started the company with that, so we didn't need to switch over. And then on the desiccant system, also very, very familiar things. We touched on the desiccant, so you've got to just be aware of handling that, maybe wear some neoprene gloves or whatnot, just so you don't get it in any hangnails or anything. But if you look at that again, the only active system there that's different is going to be those pumps. They're fractional horsepower pumps, so they are expected to last the life of the unit. We've been running accelerated lifetime testing on those for years, so we're very confident that those are going to hold up. But everything breaks, so if you did need to replace those, very easy to get a replacement, put it in, something every technician knows how to do. And then the media bed, again, lasts the life of the unit. That often surprises people. The main reason a media bed is going to fail, again, if you're going back to a cooling tower, is two things. You get sort of calcification from the domestic water that you're using, and minerals are going to just build up there since you're just flowing gallons and gallons and gallons of that water over time. Since we're only handling pure water that's been extracted from the air, no mineral buildup, so that isn't a problem. And then the other thing is you're going to get bacteria and mold that attack the binder of that media. The desiccant, as I mentioned, 10 times saltier than water. So you're talking about salt levels that are like the Great Salt Lake or the Dead Sea. Dead Sea is aptly named. Nothing could live in it because it's so salty. In the same way, nothing could live in our media bed. So back to that company I was with before, Advantage Systems, we actually were able to get our hands on a unit that ran for 10 years from them as somebody was replacing that at the end of life. And I can tell you that media bed is in perfectly good condition, lasted that whole time, and didn't need to be replaced. So we're very confident. In addition to our accelerated lifetime testing on that, field proven here, we don't need to replace that the whole life of the unit.
If this tweaks the imagination of a listener, what's the best follow-up they should proceed with?
It depends on the listener. So I would say always coming to our website. We got a great contact us link on the website now that'll get you to the right person. If you're a technician, we can get you in trust with Justin Sixt, who's our head of technicians there, and talk about getting to know the equipment. If you're an engineer, we have our rep page up there. So I think we at this point have probably hundreds of rep offices and pushing about 40 reps. We're in most states, as well as in Latin America. So if you're looking to buy the equipment, if you want to talk to a rep about specifying it, you can either reach out through there or through our sales team. We have a group of regional sales managers as well as two directors that handle, in addition to working with engineers, also onboarding reps. So if you do want to represent us in a territory that isn't claimed yet, then I would suggest kind of reaching out there as well, and we can see if it would be appropriate to add you to representation. And of course, customers can get to our website and kind of reach out to us directly or to their local rep or contractor. And then if they reach out to us, we can certainly get them in touch with the right rep or help them again if it's not an area that's covered today.
One word jumping around in my mind, that's typical. How about recharging the system with the lithium chloride salt? Is that something that needs to be done periodically?
So fortunately not. That comes back to that patent we have on exactly how we handle the desiccant. So over the whole course of the life of the unit, you're going to lose maybe a tablespoon of desiccant, and you've got many, many kilograms in there, so many, many gallons in there. So you don't need to top it up. It doesn't get consumed. It doesn't interact with anything in the air. So one thing that our sales engineers like to say is you buy one today, 15 years from now, when it's time to replace that one again, you can literally pump the desiccant out, put a new unit in, and pump that same exact desiccant right back into the unit.
Wow.
So it's fully contained, and you can almost think of it as a refrigerant, if you will. It's an open system, right? Refrigerant doesn't directly interact with the air. It goes through the heat exchanger. The desiccant does because it's just much better thermodynamically to have it interact like we talked about earlier. But it's basically a working fluid. It's pulling moisture from the air you want to cool into the building and bringing it over to the air that you're using to process on the roof.
Brings another question to mind. Is it only pulling moisture, or is there an impact on air temperature to some degree?
There's different ways you could employ it. In order to get to that very simple maintenance, that very high efficiency, we actually take what you call an isenthalpic path on the psych chart. So now I'm getting into engineering community here. But you're going to come off that coil at a certain enthalpy, which is basically a wet bulb is another way to think about it. And we're just going to ride that line of wet bulb down. So technically, the desiccant is both reheating the air. So let's say you wanted to deliver at 70 degrees Fahrenheit and 50 degrees dew point. I don't know off the top of my head, but whatever wet bulb that would correspond to probably around 60, 62 degrees Fahrenheit is the exact temperature you're coming off that coil with. So saturated air, 100% relative humidity at like 60, 62 degrees dew point and temperature, dry bulb. And you're just going to drive that enthalpy line down to 70, 50. And so you're reheating and dehumidifying at the same time.
I'm always interested, and you covered a lot of it in the maintenance, really, whether or not that needed to be filled. What is the desiccant contained in? Because it's got to be open to the airstream, obviously, but what is it contained in? What kind of a material?
Yeah, so I'll do the best I can to describe that in words, but I'd also point you back to our website where we have a couple great videos. So we have one that is about a minute long, tells you how the system works. We've got another one where our director of rep sales, Kyle Troscott, walks through the unit we had at AHR, explains what everything does. It's maybe 5 or so minutes long, so you can really get in there. But now I've forgotten your question. I'm sorry.
What contains the fluid in the unit?
The absorber is basically itself, think of it almost like a cartridge where you've got a pump, you've got the plumbing that you need. All of that is just going to stay in this enclosed system that's enclosed in plastic and has that media bed. That unit, basically the sump, the media bed, the pumping system is all where the desiccant sits. That also sits in a secondary containment as well. So if something was to happen, like if somebody, when they were doing the maintenance, forgot to put that liquid strainer back on, you would have desiccant come out, it would go into that secondary sump. There's a sensor in there. So it would say, oh, we have a leak, shut the system down, go out. And somebody goes in there like, oh my goodness, I forgot to put the strainer back on. I can't believe I did that. And they would just vacuum that out or pump it back in, top up the desiccant, and you're good to go. So there's 2 containment systems, that main one where under normal operations, it fully stays in it. And then there's a secondary sump containment in case there are any got to use errors or accidents.
Gotcha. Now, what kind of environmental conditions can we operate this in? Is there low temperature or high temperature concerns?
High temperature is going to be the same as any DX system. So we can install this thing in a roof in Arizona. Everybody knows that that works most of the time, and sometimes it gets a little bit too hot, but we're specified there. We're UL listed, so we're very comfortable that we're meeting all of the safety requirements that you need there. On the cold side, my favorite story here is we have operating in Michigan, and obviously you're not running that unit in the winter, so every fall we shut that unit down. In the spring, you basically turn it back on again, and it starts right up. So technically, there's again, getting into a little chemistry here, there's a thing called a eutectic diagram. So eutectic diagram, that tells you when it goes from being like a liquid, a solution of liquid water and salt, to solidifying out. And there's actually, again, very fascinating, different phases it could be in. So there's like an ice stage, and then there's like a particulate stage and so on, like a crystalline stage. We don't have to worry about that till you get to -40. So -40 is basically the temperature you get down to. If you happen to get that cold, what would happen is, again, it would crystallize out. And then as it started warming up again, it would turn back into a liquid. So as long as you don't try to operate it at -40 or below, you should be fine. And pretty comfortable that's not going to happen.
Not unless we get it up pretty far north into Canada. Maybe northern Michigan or Minnesota might see some of those -40 periodically, but not very often.
Not very. The coldest I remember when I was doing my PhD thesis, I spent a night outside at -20, setting up my telescope, and it was not my favorite night.
It's a good way to freeze some fingers.
Yes.
You brought university chemistry back to mind when you said eutectic diagram. I had to look it up. I'm going to have to research it further afterwards. Haven't heard that word in a long, long time. I'd like to wrap things up here just by getting you to share a summary for listeners. And you did cover the next steps for those that are interested. But what would be the ideal person for you to be in touch with right now from our community?
The main people that we're interacting with right now are customers, contractors, and engineers. So take them backwards. Engineers, we're doing a lot of lunch and learns. I asked Kyle Troscott, again, our director of rep sales, if he could give me an estimate of how many lunch and learns we've done. He said, I have no idea, but it's certainly over 1,000 at this point. So again, we've got about 6 folks going out there doing these every week. So really trying to pound the pavement. So if you're an engineer out there and want to learn about this equipment, how to specify it, how to solve the problems that are driving you crazy, that's a great way to get in touch with us, either through your local rep, and all those reps are listed on our website, or with us directly. And then contractors who are bidding today and want to give their customer basically the best value. We haven't talked too much about the value here, but everything I've said right now, you're probably thinking, oh, this is a great premium product for niche applications or people want to do the best. Because of a lot of the benefits I've spoken about and our approach here, we are at the same price or very close to the same price in a lot of applications. So you'd probably be surprised that you can get that 30 to 50% energy savings and pay back in right away, a few months, no more than a couple years in most states. So I'd say if you're a contractor that's really looking to get a great experience for your customer, if you're a customer that wants to save energy on your energy bills and do the right thing for the environment, this is something that you should definitely do, because you're not going to find a lot of investments that give you 40% return on investment like we do.
Fantastic. I think that kind of wraps us up for us today. Eric, unless you have any other questions?
No, Phil, I appreciate you coming on. It's been fascinating to learn about.
Yeah, thank you for the opportunity. It's obviously something that myself and everybody at Mojave are very excited about. We think this is the DOAS of the future and the dehumidification system for the future, and keep watching Mojave because we've also got more to come.
I add to the fact, research, business, and a great communicator. Thank you, Phil. Appreciate it.
Thanks.
Thanks for listening to this episode of the Building HVAC Science podcast. If you have any questions or wish to suggest a topic, reach out to us at marketing@truetechtools.com. Something else I really wanted to mention that's in the show notes. Tony Mormino, our friend at HVAC TV, did a recent interview with a person from Mojave. So that is a link in the show notes. You should take a look at that too. And we got a sneak peek that Tony will be headed out there to their factory in Anderson, South Carolina, to actually do one of Tony's typical HVAC TV tours. Great thing. The Building HVAC Science podcast, a production of TrueTech Tools Limited. In full disclosure, I'm the owner of TrueTech. The opinions expressed are those of my guests, my co-host, or myself, depending upon who is speaking, of course. If you're in the market for tools or test instruments mentioned in the podcast, or just have a general need, take a look at TRUTECHTOOLS.com, True Tech Tools, and you can use the offer code, the secret offer code, HVACBS for a nice discount. I want to thank you for listening and hopefully following us in Building HVAC Science. We're trying to keep you up to date on the world of building science and HVAC. And science and HVAC, it's all those three words just in a mash up together. Other great related trade resources and influencers out there include the HVACR School, HVAC Shop Talk, Stephen Reardon, HVAC Reefer Guide, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, HVACR Videos, the HVAC Grapevine, Home Diagnosis.tv, AC Service Tech, Measure Quick, and HVA Chicks. Hope you enjoyed this episode, and we hope to have you back soon for another great episode. Hey, I think they're great if no one else does, of the Building HVAC Science podcast. Take care.